All right, on today's episode of the Power Podcast, I'm joined by Dave Thomason. He is Industry Principal of Global Power Generation with OSIsoft. Dave, thanks for joining me, and if you don't mind, just give it a little bit of background about yourself and about OSIsoft.
Thanks, Aaron. I am David Thomason. I've worked in the utility industry for 29 years, basically with one foot in IT and one foot in OT the entire time, trying to apply business solutions. I came to OSIsoft in 2011. Previously, at my previous firm, we were big customers of OSIsoft. For those that don't know anything about OSIsoft, it is a company that was a pioneer of what people now call digital transformation. Company's been in business for 39 years. We have, software in over 140 countries, and the software is opened up to be able to be in any industry. Even though power generation is one of our largest industries, we're also very big in oil and gas, metals and mining, pharma and life sciences, and chemicals. So the drive for the use of information helps us stay on our A game to be able to provide a solution that actually works across all industries.
Data analytics is a big topic. We actually at Power, we have the Connected Plant Conference, which is going to be held down in Atlanta, Georgia next February. And we cover a lot of the information and how you're tying analytics into, predictive maintenance and real-time monitoring, things like that. What do you see happening in the industry when it comes to data and what people are doing at power plants to incorporate these information into dashboards and things and operate their plants more efficiently and reliably?
Data and analytics has been, kind of a really on the IT hype cycle for a few years now, right, with the push of big data and such. But to be honest, most of the really big data solutions were focused more on a retail type solutions and stuff, and are now being adapted to be able to really work with OT type of information. But that's not always the right fit, right? There's other ways to get analytics done, and they may be a lot more efficient. And so what we've seen is kind of an evolution of what we're calling layered analytics. Like, where should the analytic actually take place? As close as you can to the real-time data stream, so it happens in near or real time, or maybe a level 2 analytic that actually is feeding into things like advanced pattern recognition or machine learning. Now, that can be done in a big data environment, or it can be done actually with, a third-party application, or by feeding function calls into libraries like R library and Python and such. So we see customers taking now a different, maybe a more pragmatic and cost-effective approach to their analytics. But also what we see is the influx of additional data, right? Not just the operational information from the assets, but combining that information with future data in forecasting, with information around the market, whether it be weather, whether it be scheduling, whether it be pricing, those type of things, and being able to compare in real time and be able to view how you're doing with that ingress of additional data.
And how does that cause operators to maybe alter decisions that they're making? Like, will it keep a plant online in certain situations, knowing that it's going to be needed, and that, shutting down and starting up wastes a lot of energy? Is it those types of decisions that it helps drive, or what are they really getting out of this, and what value are they finding with your analytics?
So you can do a multitude of things, right? One would be that, you really want to be able to monitor the health of your assets in real time. So it's kind of a movement from, periodic condition assessments around equipment and assets and move to a more online condition monitoring. This way, you're more situationally aware of actually how things are running, what's going on right now, and maybe which is something that's heading south that may affect your operation and maybe your ability to generate what you've been asked for. Getting a heads up on that kind of information greatly lets maybe the commercialization or the dispatching or organization make maneuvers around a potential failure or something that you're actually that's pending that's going to affect your ability to produce. it'll also put a more rationale around, well, what is the next thing we need to dispatch, or how else are we going to make this up, and make sure you're making the proper economic decisions around that as well.
And are these tools that require a great deal of integration, or are they things that are easily added to a system that a plant may already have? How difficult is it to add these new tools?
Actually, that's probably the thing that's changed the most, right? Technology and all the advances in the IT world, right, have made the technology to be able to do these things much easier than they were in the past. I can remember years ago, it's hard was just to get a pump curve or a performance curve on a piece of equipment. Now you can have those things running live and in real time. You do this via, if you're using the Pi system, of course, you're going to be using this via what we call configuration of analytics as opposed to a lot of programming. It's really almost like a user self-service BI to the operational data world. And so this allows you to create little small calculations, which may be a rate of change calculation, right? To be able to say this data usually doesn't move at 17%. It normally only goes up or down around a 15% rate. Well, you can put a little calculation on there and say, hey, when that happens, I want you to automatically not only mark it in the database as something I want to look at, but go ahead and maybe send to me an email. And that email would contain a link to the actual data in the screen that I need to look at to view what's going on. So having that early awareness is what greatly affects how you're going to operate. And then, of course, that's down from the smallest pieces of equipment that you may have all the way up to managing entire fleets of assets. We have customers that are managing assets, all over the world, and they're trying to do optimization in multiple markets. So the more data that they get their hands on, the better that decision making is.
And so if we could take a look at maybe some examples, I know OSIsoft has done some work at some hydro plants, and one in particular, I guess I don't know if I'm even pronouncing this right, Itaipu down in Brazil. What have you guys done down there?
Well, the plant in Itaipu, and I'm probably mispronouncing it as well, is actually one of the largest hydroelectric facilities in the world. I think in 2016 they made over 103 million megawatt hours. It is an enormous facility. It's 14,000 megawatts. They have 2,700 megawatt units there. It provides around 14% of the power to Brazil, the entire country of Brazil, and I think around 86% of the power to Paraguay. So the criticality of this asset is enormous. Now, they've done some very unique things there. One thing that they decided to do is, hey, we're going to use this real-time data system to actually monitor the structural integrity of the dam itself. So there's key blocks within the hydroelectric facility. These blocks have now been instrumented with various instruments that can detect movements, and that now runs through what we call our asset framework that sits kind of a meta layer and an abstraction layer on top of your OT data within the Pi system. They actually use that as what we call was the old Bell Labs fault tree analysis, which they built within that hierarchy. So now they can take multiple instruments, feed them in, and get an accurate reading of maybe something is moving or shaking in a way it might not should. That becomes an alert. That alert not only contains where these things are coming from physically, they'll actually have a little map that shows where it's coming out, but also the impact. So this is giving them an ability to monitor the health of the whole structure of that facility. It's such a cool use case that I really wish I could see this expanded across multiple places, of course, multiple hydro dams, but also even things like tunnels and bridges and such, which you see in our decaying infrastructure. The same technique could actually be used.
It's really an amazing thing that you could monitor the health of a structure as big as a dam and actually see these little movements. I think it's amazing.
Aaron, when I first saw their picture, they have a whole technology complex because of that criticality of that facility, and their technology center is downstream from the dam. So when I first saw the photograph, I go, okay, I know your guys' interested in making sure this is monitored closely.
Right. Yeah, definitely don't want that to fail when you live right downstream of it. Now, another thing that's often complex is managing water inventory at hydro facilities. And I think you mentioned they're doing this in a very unique way in certain parts of the country, even out in California. How is that being done?
Well, we have customers like PGE. We have customers like Australian Gas and Electric down in Australia, and others like Vattenfall and such, which are doing things to manage their actual resources themselves. Now they're going beyond just managing the actual reservoir they have. They'll actually go up and measure the depth and the density of the snowfall that are in the mountains that feed into their reservoir or their lake systems, and they'll count that in and measure it as inventory. So they'll go up there periodically using manual data, entering the information. It's coming back into their system, which then they can calculate and use as put into future data as new volumes that are going to be there. Now, this allows them to optimize that resource of the hydroelectric. Let's say we're in early spring. There's still snowpox up on the mountains, and you see a big rainstorm coming. Like, it's not going to snow; it's going to actually rain, which means it's going to wash a lot of that down quickly. This, of course, would give operations the idea that they really need to run water from that reservoir at least as much as they're allowed to, and generate power off of that because they know it's going to be refilled soon. So this is that whole concept around using data and information in ways people really weren't planning to use in the past, but being able to have that available to them to help them make those types of decisions. And also with the supporting efforts that hydro really helps the variability around wind and solar and such assets. So I believe hydro assets, their actual importance and use within our systems is increasing. It's increasing heavily. They're great at base load, but they're also great at doing load following and such of the variability of those other types of assets.
Yeah, no, I think that's a great point. It is probably the most easily adapted to changes in the wind and solar output. Just easily ramps up and down as compared to some other that take more time and more effort. So, and I guess a lot of these this information that they're calculating, these can all be rolled into dashboards as well, I assume, so you can see this in real time and managers can make decisions based on what's happening out in the field and in these different areas.
Yeah, that's one of the key things that's happening. So you can imagine you're monitoring not only maybe your entire company's worth of assets and having that roll-up capability from those assets, but you're also looking at them site by site, right? And so you're being able to optimize the usage of those resources, being able to see that in real time, and then not only seeing what's going on in real time, but what's expected. What are we expecting to do within the next hour or within the next day? Or what does our forecast keep telling us how we're going to operate? And so we see this a lot within the ISOs as well, like California ISO and ERCOT, and PJM and such here in the United States. They're really advanced users of future forecast. A lot of people think when they're forecasting wind, there's like one wind forecast. No, there's wind all over the place going in different directions through valleys and such. And all that has to be looked at individually to really be able to anticipate, what do we expect our wind to create tomorrow? And what are these farms are going to produce? I know in Texas we have over 20 gigawatts of wind. We're at the most of in the United States. And to manage that amount of resources optimally with all the other resources you have, whether they're nuclear or coal and gas and hydro, that's a big balance that people are doing at these ISOs. And they're really good at it. To be honest, they're absolutely amazing and actually setting, plowing the field for everybody else's use to say, here's how, to use future information in a very good way. And then as you have those full forecasts, and they're tuning them every day as the forecast gets closer to now, and then now in real time, you will measure what those forecasts were versus what you're actually producing and how you're responding to it. And if you're off, well, this creates a circular improvement environment that allows you to make sure that, hey, maybe we need to tweak this forecasting a little bit. Maybe we need to look at solar radiance a little differently in this area. And so being able to have that information not only helps you in the now, in the real time, but also helps you keep improving how that operates.
Great point. Well, Dave, I appreciate you taking the time to talk to me. Is there anything that maybe I haven't touched on that you still think is important to get out to the listeners?
Well, I think don't be afraid of a journey that takes you on a digital transformation. It's okay if you're starting at an area that maybe you're just beginning, you're just starting to use the information. Many people are on different parts of that journey. Some are a lot more advanced, but go ahead and start, and you'll find that the tools and the techniques you get to learn from others, it'll happen faster than you think it actually would. So and please look up all these use cases and stuff. They're out there on OSIsoft.com.
All right. Thank you for your time, Dave.
Cool. Thank you, Aaron.